Hi, my name is Ben Tokar, and my presentation is on extreme radiation. What is radiation? Radiation is a discharge of energy through the movement of subatomic particles. Radiation happens in high-energy particles which produce ionization. Ionization is when an atom gains either a positive or negative charge through acquiring or losing electrons to form ions. What is the most and least harmful radiation? The most harmful form of radiation would have to be the gamma ray, since it has the most penetrating power. It can go straight through your body and deal tons and tons of damage. The alpha particle, on the other side of the spectrum, the alpha particle has little to no penetrating power. It can do pretty much nothing to you, except that it's the most ionizing and the gamma ray is the least ionizing. If you didn't know, an alpha particle is the composition of 2 protons and 2 neutrons. Alpha particle is a common result of alpha decay, in which as seen in the picture, in which an atomic nucleus will shed an alpha particle, or 2 protons and 2 neutrons, to help stabilize the atom, except that it will also change it into another element. The alpha particle's composition is exactly like the helium-4 atom, or helium-4 nuclei, as shown in the middle of the picture. How is radiation harmful? Radiation is harmful if you get a lot of it within one day. It can be pretty fatal. So, radiation isn't harmful in tiny doses, but in low doses or middle. So, say you get 30 rads of radiation, it will probably give you sickness, nausea, and you will not feel really good. You'll have a lot of vomiting, and you'll just feel like garbage. With 1,000 rads in one day, it could be fatal. You could die. You could get super, super sick, way worse than just 30 rads. It would do so much. You would just feel awful if you didn't die. Okay, how have humans harnessed the power of radiation? So, the power of the gamma ray is not to be messed with, but in the right hands, the gamma ray can be converted to electricity. Gamma rays can produce more energy than regular light energy, have a shorter wavelength, and have a higher frequency, which are great attributes to make it a candidate for a longer lasting energy source. Much better than regular energy, and it works way better too. As shown in this picture, the gamma ray has an incredibly high frequency. The wavelength is super short. It's a really good candidate for a longer lasting energy source. Thank you for watching my video.